In Muroran, a city in Hokkaido, a project is being conducted to deliver hydrogen at low pressure in cylindrical tanks containing a hydrogen-absorbing alloy to residences and small businesses utilizing an existing gas delivery network. This is the Shukuzu wind farm, a wind power generation facility owned by Muroran City that has a rated output of 1,000 kilowatts. This power plant generates electricity using wind power, a type of renewable energy, and uses that electricity to produce hydrogen. This is a hydrogen production plant in Muroran, at which hydrogen is produced and stored. One section of the white building on the left produces hydrogen with a water electrolyzer. The hydrogen produced here is then brought to the blue building on the right, where the hydrogen is put into cylindrical metal hydrate tanks. Electricity generated at the Shukuzu wind farm is delivered to the hydrogen production building via a power receiving panel. Hydrogen is then produced in a water electrolyzer in this building. The hydrogen produced here is then transported to the hydrogen filling building, where it is put into cylindrical metal hydrate tanks. The cylindrical metal hydrate tanks contain a hydrogen storage alloy that can absorb hydrogen into the metal, thus enabling the safe transport of large quantities of hydrogen at low pressure. Since these tanks can be loaded onto existing liquefied gas delivery trucks, it is possible to utilize the existing delivery network, which reduces supply costs compared to setting up a new delivery network. This will also help spread hydrogen use to small-scale end users, such as ordinary homes within the delivery network. Let's now take a look at where the hydrogen is actually being delivered. This is Mitara Muroran, a roadside service area visited by around 900,000 people every year. The Kujira Shokudo, a restaurant located within this service area, uses hydrogen. Cylindrical metal hydrate tanks delivered by truck are stored on the service area grounds. The hydrogen supplied by the tanks is used to make hot water in a hydrogen boiler located at the site. To ensure stable operations, it is sometimes necessary to speed up hydrogen extraction and increase the amount of hydrogen supplied. Since hydrogen can be extracted more quickly when the tanks are heated, waste heat from the boiler is used to heat them here. The hot water made with hydrogen is used mainly in the restaurant's kitchen. This is the staff dormitory of Muroran Institute of Technology. A hydrogen fuel cell installed within the dormitory uses the hydrogen supplied from cylindrical metal hydrate tanks to generate electricity and heat. Electricity generated from the hydrogen is used in areas inhabited by staff, and the heat is sent to water heaters for use in bathrooms and other places. This is the Muroran Youth Hostel, a lodging facility. Similar to the roadside service area and the staff dormitory, the hydrogen delivered in cylindrical metal hydrate tanks is used to make hot water in the hostel's hydrogen boiler. The hot water made in the boiler is used in the hostel's public bath and restrooms. This is the Muroran Advanced Center of Industrial Technology and Management. Hydrogen is used here to heat roads and to melt snow and ice in parking lots, since snow accumulates here each winter. When snow begins to accumulate, a hydrogen boiler fires up and heats up an antifreeze liquid used in a road heating system. Sent through pipes laid below ground, the heated liquid melts snow and ice on the parking lots. This is a privately owned metal processing factory which manufactures and fabricates steel products. Here, hydrogen is used to cut steel with hydrogen gas-powered machinery. Cylindrical metal hydrate tanks delivered here are warmed with an electric heater to extract hydrogen. Since hydrogen gas has a transparent and colorless flame, it is necessary to make the flame visible to ensure safety. Therefore, in this factory, the hydrogen is mixed with methane gas, which emits light when burned. The processed hydrogen is used to operate the factory's hydrogen gas steel cutter. This is the Muroran City Aquarium. This demonstration project utilizes not only the produced hydrogen, but also the oxygen byproduct generated during the hydrogen production process. Oxygen generated during the production of hydrogen in the water electrolyzer at the hydrogen production plant mentioned earlier is collected and stored. This byproduct oxygen is sent via pipeline to the water tanks in the adjacent aquarium, where it is used for breeding. In these ways, Muroran is using renewable energy and existing infrastructure to create a hydrogen supply chain that covers the entire process of producing, storing, transporting, and consuming hydrogen. This will help reduce the cost of hydrogen and diversify hydrogen consumption with the aim of realizing global decarbonization.